At this step of the tutorial, you will learn how to design a parametrical concept of the furniture, define the space for standard subcomponents like drawers, etc., and so on. Demonstrated design technique is one of the many possible ways of modeling. Woodwork for Inventor does not apply any restrictions on the design methodology, but focus on the final results instead. However, the way we show you is based on our long-standing practice and it illustrates proven and optimized ways of modeling. In this tutorial, the shape of the furniture will be quite simple, but it's done to make explanation clear and easy to understand. In real life, you are limited virtually by your imagination. Good luck! Let's run Autodesk Inventor with Woodwork for Inventor installed. Use New File menu to create a new part. It will be used for a 3D skeleton of an office table. Make a new sketch on XY plane and draw a simplified top view of a model. In our case, it would be enough to draw a rectangle. On a sketch toolbar, choose two-point rectangle and start to draw it at origin point. If you need to move a view, just hold your mouse wheel pressed and pan the camera. During the modeling, you can define parameters. Just type parameter name and then place equal sign and enter the value. When you define the width, use Tab key to jump to another input field and enter the depth value. Scroll the wheel to change the scale. Finish the sketch and click on the home icon on the top right corner to fit the sketch on your screen. Now use Extrude command and define the height of the box. There is the tool called View Cube. It is used to change the orientation of your model. So we can look to our table from the top and set this view to be a top view on a view cube. Then you can define a home view to match isometric view of your model. Now let's see how parameter works. Click on the FX sign on the top of your screen. As you can see, in the equation field you can type how the value is calculated. Moreover, you can immediately see the changes on the model. Add new parameter to define thickness of the board used in our design. Let's say that we have different thickness for the desktop as well as for the body panels. We can refine the shape of a table a little bit. Start a new sketch on the top surface. Project perimeter geometry. And draw a broken line. Use dimension to define the shape of a line. Notice that the color of the line changes when all possible dimensions have been placed. Now finish the sketch and use Extrude command. Choose the smaller, closed region. You may need to wait a little before selection window appears. Now select Extend option through all. Autodesk Inventor is smart enough to automatically enable cut option in the extrude window. Now we can add some fillets. To do this, click on the edge and choose fillet. Then pick another edge and set fillet radius. You can use different radiuses of fillet in one single command. Now, when we define the basic shape, it's time to use Woodwork for Inventor functionality. Click on the Skeleton Dress Up tab and use Dress Up function. Run Dress Up tool and select the box that we just made. It becomes transparent automatically for better visibility. Now select the top surface and select desktop thickness as a parameter to generate the shape of the desktop. When it's done, Pick a side panels, but choose the side panel thickness as the parameter in this case. For convenience, we can hide the skeleton body. As you can see, panel intersects. To fix this situation, we can use trim to trim the panels. Select the panels that need to be trimmed and what is used as a boundary object. Now we will define the space for cases on the bottom. Use a sketch to draw the rectangle. Define its size and offset from the side. Then use extrude to make its shape. Because this box will be a new component, make it as a new solid body. Later, during the design, we will define a box assembly to place it inside of this box. iBox is a parametrically driven prototype of the furniture that can change its size to fit inside of the design. Now let's design another box on the other side. To make our work more convenient, we can set those boxes' representations as a skeleton. The box on the right will contain the drawers. First, let's draw the Inset Facade. In order to do this, we need to know where the side panels will be. Let's project the external contour of the front of the drawer and make an offset by the thickness of the body panel. Now we can measure how much space we have for the drawers. Let's say we want to have 3 drawers. However, 5024 is not divided by 3 because the sum of the digits for this number is not divided by 3 equally. So we can add 5 plus 2 plus 4, it's 11, which is not divided by 3 as a real number. Let's fix this situation by going into the parameter list and finding the one that defines the height of the drawer. It is not named yet, so let's change the name to make it more descriptive. Now we can copy the parameter name and use it in another equation. Now we get the sum like 5 plus 2 plus 5, it's 12, which can be divided by 3. This means that this number can be divided by 3. Let's define the height of a drawer to see if it is an even number now. It works flawlessly. Finish the sketch and extrude the facade. Make a new solid that goes inside of the box. Now facade is too big. Let's reduce its size. Make a new sketch on a facade. use an offset by 1.5 mm, and then do an extrusion with intersect option enabled. Use the back side of a drawer to draw the drawer box. Draw a rectangle first, then use constraint to position it symmetrically along the vertical line. Now connect the rectangle with the sides of the facade. And define the box offset from the top and the bottom. Now we can use extrude to extrude the box till it reaches the back side of a table. Because the drawer must be smaller, use direct modification tool to reduce its size. Now, no matter what is the depth of the cabinet, the drawer will be always smaller by the given length. There is few more things to do. First, let's design a support for the desktop. In order to do this, make the box visible again and create a sketch for the supports. Use coincident constraints to place the rectangles in the middle of the box. When sketches have been made, use extrude to make two new solids that will represent support parts. Now let's add an optional feature. Let's say that some of our table will have a wall between them, so we can use direct tool to pull the side panel then make a new sketch to build its shape. So we can draw a broken line, do an extrusion, then add the fillets. Now you can save the file. It's important to do this inside of your workspace folder. Lastly, let's give the descriptive names to the solid bodies that we made. Use Manage, Make Components to make a new assembly. Now, when we are on assembly environment, we can make our conceptual objects transparent. Finally, we need to save our work. So, now we are ready for the next steps.